Hi, my name is Mustafa Adabi. I have a master's degree in geotechnical engineering from Iran University of Science and Technology. In this video, I want to present the result of my research and code implementation about CSSM, or Critical State Soil Mechanics Constitutive Models. I've developed a MATLAB code template to demonstrate the behavior of all types of critical state constitutive models. It's worth mentioning that different types of critical state models can be implemented by some minor changes in my code. To show how this code works, I've selected a model presented in this ASCE paper. Before we go to the code, it's better to mention two things. First, as you know, the result of the actual test is so crucial when you want to calibrate and see the behavior of a soil constitutive model. This code is designed to show the total results of a complete drained and undrained reaction test. And the second and the most important thing about this code is that this code is strain controlled. It means that the desired strain, regardless to the types of the analysis, is given to the model and the code by defining a matrix. I call it stiffness matrix here. According to the model, updates the stresses and other parameters consequently. You may ask why being strain controlled is important. It's a good question. The reason is that the constitutive models, which is used in different FEM software like Abacus and Plaxis, works in the same way. It means that in each step of the analysis, the changes of the strain or de-strain, which is specified by software from previous step, is given to the constitutive models, and the models updates the stresses and other parameters in the same way. So we can easily implement this code in FEM software and analyze more complicated problems. Now let's go to the code.
This code can be divided to 9 different sections. The first one is the input section. All soil properties and model parameters, no matter how many they are, can be defined here. By changing these variables, you can simulate the behavior of this constitutive model in different situations. Some of them are calculate parameters like initial consolidation pressure, confining pressure, M, lambda, and some of them are model parameters like C, A, etc. For understanding these parameters, you can refer to the paper I mentioned before. In pre-calculation section, some parameters which is required by model is calculated in advance. After that, a block memory in MATLAB is specified for each matrix. And in the next section, in initialize section, the current situation of the soil, before starting the test, is evaluated and calculated. This section works the same as initial step in Abacus software. In two sections, section 5 and section 8, the initial and the final yield surface of the soil are calculated. This will be used for showing the stress passes from a start to the end of the analysis. Section 6 is the core of the code. The unique stiffness matrix is generated here. In section 7, as you can see, the strain is generated according to the analysis. As I mentioned before, this code is strain controlled, and the stress and the other parameters are updated according to the strain changes. Finally, in the last section, all variables and matrices are printed in a spreadsheet. When I run the code, a result spreadsheet is generated in MATLAB. Let me run it. This spreadsheet will be updated each time I run the code. By changing input value and running the code again, I can simulate the model in different situations. Let's open the result spreadsheet. All model parameters initial and final yield surface, and the value of P, Q, void ratio, and others during the test process are stored in this spreadsheet. Working with this spreadsheet is hard, so I developed another spreadsheet using one of the Excel feature, VBA or macro, to facilitate the work. Let me open it. First, let's clear all data by pushing this button. I can easily import the result spreadsheet here and see the trends and the graphs here. The Excel opens the result Excel and copy all data to its specified position in new spreadsheet. I have run the code for different OCR and different temperature. The result sounds reasonable.